of record, but this was just a recap of the thing. So let's anyway leave it to that. Let's get started with the remaining topic. There's only one small topic remaining in this chapter, and then we'll be done with this. And this is a very easy topic actually. So in this part, we are going to talk about the decimal expansions of irrational numbers and rational numbers, revisiting rational numbers and their decimal expansion. So if something is a rational number, do you people remember how the decimal expansion of a rational number can be like?
Terminating and non-terminating and recurring.
Yes. Good. The decimal expansion of rational numbers. I think we had seen this in detail, so all of you should remember it. So it can either be a terminating decimal, or if it is non-terminating, it has to be recurring. Okay. Now, if you have been given a fraction, let's say, if you have been given a fraction, let's take the example from here itself. Yeah, let's say 3 by 8. So just by looking at it or doing some minor calculation without doing actually division, can you figure out whether the decimal expansion will be terminating decimal or non-terminating recurring decimal? Without doing the division. Does anyone know any method or trick to know whether this is...
It should be in the form of 2 power m into 5 power n.
Yes. Okay. Good. We'll talk about that. And one more thing. Can the decimal expansion of this thing, is it possible that it is non-terminating and non-recurring? Is it possible?
Yes.
Yes or no? I couldn't hear you. I'm not only asking about this example, I'm talking in general, okay? Is it possible to figure out that this is non-terminating, non-recurring? Can it be non-terminating, non-recurring? Is it possible to have a non-recurring?
Yes, sir.
It's possible, okay? See, if something is non-terminating, non-recurring, what kind of number it is? It will become an irrational number. Correct? If something is non-terminating and non-recurring, it will become irrational. Okay, guys, just confirm once. Like I have taught you about all this, no? In this class, have I taught you or not?
Not in this class.
Not in this class?
In 9th, sir.
Okay. Okay, then let's do one thing. Let's do a quick recap of that decimal expansion of numbers. Okay. Everybody knows decimal numbers. How many types of decimal numbers can be there? It can either be terminating or non-terminating. Everyone knows that? Terminating and non-terminating decimal. You would have studied this in your earlier classes, no? Just speak up, guys. I need to know how much you know so that I will go into that much detail only if necessary. Otherwise, I'll have to teach everything again. So decimal numbers can have either terminating decimal expansion or it can be non-terminating. So we're just writing as terminating and non-terminating. Give me an example of a terminating decimal number.
0.5.
Yes, 0.5. It terminates after how many places of decimal?
1.
Yes, it terminates after one place of the decimal. That's all, one place, 5. Give me more examples, other people. Terminating decimal, give me an example. Yes, go ahead. Any number, just throw some number at me.
1.2.
1.2. So let's take more bigger number, 1.237. Let's say. So this has three decimal numbers, and after that it stops. So this is a terminating decimal again, right? So everybody understands the idea of a terminating decimal. It means that the decimal numbers will stop after certain number of digits. So it can be after 1 digit or 3 digit, or it can even be after 40 digits. Doesn't matter how many digits. It is not the matter. It can be any number of digits, but it should stop after that. So that is what the terminating decimal is. Now, what is non-terminating? Give me examples of non-terminating decimal.
0.1515 keeps on repeating.
Yes, very good. So 0.151515 keeps
Root
repeating. So
3.
this is a non. Root 3. Is it non-terminating? Yes, it is non-terminating. That is true. So, but if we are, don't give me an example like root 3. You should give me examples in the decimal form. Yes, it will be the decimal expansion of root 3 will be non-terminating. That is correct. Whatever you said is right. But as of now, I want the decimal form. So give me some numbers in the decimal form. So the idea is the number will not stop. It will keep on going, not only repeating. We don't care about that. I'm just talking about non-terminating right now. That means it doesn't terminate. So the number could be anything. Like I can have 5.010010001 and so on. This is also non-terminating. And I can have 3.141537 896354. If it keeps doing, it keeps changing. If it does not repeat or does not end, still it is terminating decimal, non-terminating decimal, I mean. Okay. So based on that only, this non-terminating decimal, it can be divided into another 2 types. So what are those 2 types? So either same digit will keep repeating, or different number keeps coming again and again. Not again and again, I mean to say different numbers come one after the other. So based on that, there are some names, right? Do you people know? Non-terminating decimals can be
Recurring and non-recurring.
Yes, it's called a recurring, which you can also call it as repeating. Recurring means repeating, and non-recurring means non-repeating. It does not repeat. Okay, so I will take examples of non-terminating decimals separately for recurring and for non-recurring. So give me examples of recurring now. Examples of recurring non-terminating decimal.
1.7878.
1.787878 ... which we can write it as 1.78 with a bar on it, right? Everybody knows that?
Yes.
Okay. More examples?
Sir, 5.108, then 108 goes on dot and bar, sir.
So this is also an example of a recurring non-terminating decimal. Remember, these are also non-terminating.
Sir, that is 5 point. No, sir, you have written 1.
Yes, sir. You have written 1.108, sir, bar.
Okay, thank you. So Everybody understands this non-terminating recurring?
Yes, sir.
Okay, now give me examples of non-terminating and non-recurring numbers.
Just 1.8.
1.8, will it be non-terminating, non-recurring?
No, sir.
It becomes terminating, no? It terminates after 8. So this is not an example of non-terminating, non-recurring. This number should be non-terminating. It should not end, because 1.8 becomes an example of a terminating decimal, right? Is it clear?
Yes, sir.
Yes, sir.
1.8 can be an example of a terminating decimal, not for a non-recurring. Non-recurring means it should be non-terminating also.
Sir, then 1.987654.
Yes, 1.987654. Keep on going, and with different number keeps coming. Okay, and it should not end at all. It should keep on going infinitely. But it's not possible to write numbers like that.
0.1010010001 like that, sir.
Yeah. So if some of you had studied earlier, you should remember that we learned how to write non-recurring, non-terminating numbers. We can give a pattern to it, but it will not be repeating. For example, I can say 0.01, 001, 0001, and then dot, dot, dot. It means the pattern is repeating. First the 01 comes, then the 001 comes, 000, then 4 zeros will come, and then there'll be a 1. So there is a pattern, but it is not repeating. It's not the same number coming again and again, right? We can't put a bar on anything. We can't say that 0.01 bar, because if it was 0.01 bar, then it will be 0.0101 and 01, right? This is different.
Yes, sir.
Okay. Same way, I can write more examples. I can write 5.31, 311, 3111, and so on, and more examples like that. So everyone understands that now? Decimal numbers can be of terminating, non-terminating type. Non-terminating itself can be of two types: non-terminating recurring and non-terminating non-recurring. Okay, so out of these numbers, terminating and recurring both are rational numbers. Okay, they are rational numbers. So if something is terminating, or a number like this, which you can put a bar on it, non-terminating recurring, or both these types represent rational numbers. Only this guy alone over here represents the irrational number. Everyone is clear with this concept? Confirm quickly, give me yes or no.
Yes, sir.
Okay, fine. So now that you know which ones are rational, which ones are irrational, now let me ask you the same question which I was saying. So if some number is written in the form of fraction, let's say okay, let's say if I give you a fraction like this, of course it's not easy to divide this, no? That's why I gave you this number, but you should not be able to divide it. Now, just by looking at this number, can you tell that this number, can it have non-terminating, non-recurring decimal expansion? Can it have a non-terminating, non-recurring decimal expansion? Is it possible?
Yes, sir.
or is there no way to find it other than doing actual division? Okay, someone was
It's
saying.
non-terminating, sir, since the decimal, the denominator ends with 7, so it won't be a multiple of 7. Sorry, it won't be a multiple of 2 as well as 5, sir. So it is not in the form of 2 power m into 5 power.
Okay, that's very good. So that what does it tell you?
That the decimal, the fraction won't be terminating.
It won't be terminating. That is, it is non-terminating. Now, if it is non-terminating, can you also tell me whether is it non-terminating recurring or non-recurring?
Cancelled or not, no, sir. If
Uh-huh.
they get cancelled, if they get cancelled
Mhm.
both, then the denominator might change, no, so then it would be
Yes.
divisible.
Yes, Charan also has a right point. So since this number we have not tried to cancel, there is a possibility that if you cancel with the numerator, it may become only factors may be 2 and 5 in that case. Anyway, some of you, if you don't know what we are talking about, just hold on for a bit, okay? I will explain. Yeah, and those of you who understand what I'm saying, so if you cancel with the numerator, maybe, but let's say it's not a factor, it is still, I'm saying, I'm giving you a hint that it is non-terminating, let's say. Now, if it is non-terminating, it can be of two types. No, it can be either recurring or it could be non-recurring. Which one is it? How can you find out? Is it possible to find out whether it is recurring or non-recurring? See, it's a very easy thing to figure out. Don't think too hard. It's not complicated. No one can think of this. Answer is there in front of you over there. Of course, it's in hidden form. Try to recognize why it can be one of the things recurring or why it can be non-recurring.
Sir, like the denominator is 98736, different number.
Mhm. Okay, fine. So you have thought about all the complicated things, but you did not think about a simple thing. What is the numerator? It's an integer, right? And what is the denominator? This is also an integer. So if you have something written in the form of integer by integer, is it a rational number or irrational number?
Rational number.
So if
Rational
something,
number.
so if it is a rational number, can it have non-recurring decimal expansion?
No, sir.
Because non-recurring will happen for irrational numbers only. We know that, just now I explained that. So that is the idea. I want you to understand it very clearly. Because I have already written in the form of P by Q, that means of course it is a rational number. So if it is a rational number and I know that it is non-terminating, then it can only have a recurring or repeating decimal expansion like this. So tell me if you're able to understand the idea which I'm trying to push through to you people. Did you understand what I'm trying to say?
Yes, sir.
No, sir. Sir,
Okay.
I am having confusion. I can't understand this part, sir.
Okay, Tanushri. See, just now I explained, did you understand this part that irrational numbers are like only irrational numbers will have non-recurring decimal expansion. This one over here.
Yes, sir.
Only irrational numbers will have non-recurring, non-terminating decimal expansion. Okay.
Yes, sir.
Now I have already written this number 3751 by 1987336, whatever, blah, blah, whatever it is. It is in the form of P by Q, no? Numerator is also an integer. Denominator is also integer. And you see the denominator is not equal to 0. So is this a rational number or an irrational number, Tanushri?
Rational number, sir.
This is a rational number, right? And
Yes,
if
sir.
something is a rational number, then only possible decimal expansion are either it has to be terminating decimal expansion or it can be non-terminating recurring decimal expansion. Only these two are possible because rational numbers can only be terminating or non-terminating recurring. Does that make sense? So this can never be non-terminating, non-recurring. This number can never be non-recurring, non-terminating decimal. So that's what
Yes,
I'm
sir.
trying to tell you, okay?
Yes, sir.
Okay. Now, it's very easy to eliminate this guy that something is non-recurring, non-terminating. Very easy to figure out because if
Sir?
something is written in the form of P by Q, just hold on for a second. Let me complete this idea. Remember your doubt, okay? Whatever you have, you just remember. Ask me in just 2 minutes, okay? Okay, so what I'm saying, if you have been given a fraction like this, then it's very easy to eliminate that this can never be non-recurring. So now only choices are either it is recurring like this or it is terminating decimal like this. Now, how to find which one is it? Is it terminating or recurring? There is a trick for that, which some of you were just talking about. So I'll explain that to everyone. So if you have a fraction given, what you do, don't even look at the numerator as of now. Just look at the denominator and try to do the prime factorization. So of course, I will not ask you to do the prime factorization for this number. It's very complicated. So let's.
A denominator is a prime number, sir.
In this example, you're saying?
Yes, sir.
No, I have just randomly put some number over there. I don't know whether it's prime or not. Okay, probably it looks like a prime number, but wait. Yeah, it looks like a prime number probably, but don't think about all that. This is just random some number. I put it over here. Okay.
Yes, sir. Yes, sir.
Yeah. So this is not the number which I'm going to ask you to do the prime factorization. So let's take another example. So what are we trying to learn right now? We are trying to find out or to check if a given fraction has terminating decimal expansion or non-terminating recurring expansion. Non-terminating recurring decimal expansion. Why did I not include the third type? Because third type is very easy to eliminate. If something is given as a fraction, so of course it cannot be the third type, that is non-terminating, non-recurring. It cannot be non-recurring. That is why we only fight is between the terminating guy and the non-terminating recurring. These are the only two contestants to figure out which one it is. Either it's terminating decimal or non-terminating recurring. Fine. So this is what we are trying to learn. Let's take some examples from the book itself. Yes, let's take it 7 by 80. This should be an easy example to start with. So let's say this is a fraction given to you. Like I said, it is in the form of P by Q. It is a rational number. So of course, it cannot have a non-recurring decimal expansion. It is either terminating or non-terminating recurring decimal expansion. Which one is it? For that, simple trick is do the prime factorization of denominator. So do that. It will be 40, 20, 10, and 5. So you can write 80 as 2 to the power 4 into 5. Now, only thing you need to check over here is look at the prime factors. What are the prime factors? If it is 2 here, okay. 5 here, okay. But if other than 2 and 5, any other number comes, then there is a problem. It will not be terminating. So what I'm trying to say, if in the or we can say if the prime factorization of denominator has only 2 or 5. No, remember, it doesn't have to be 2 and 5 both at the same time every time. It may be only 2 possible. You may have only 5s, that is also okay. But other than, okay. So hopefully everything is getting recorded. So yeah, what I was saying is, you factorize the denominator, and once you do the factorization, if you look at the prime factorization of the numbers, and if you have only 2 and 5, then it will have a terminating decimal expansion. Let's prove that. Okay, so 7 by 80, just now I told you it has a decimal expansion of 2 to the power 4 and 5. Okay, so if I want to convert this to a decimal, what should I do? One way is the difficult way. Do the division like a donkey, all the hard work. It will take half an hour to do the division and you will get the answer. Okay, but if you are smart enough, what will you do? Anybody knows? What's the smart way to convert this into a decimal? Okay, nobody can think of. Let me give you the idea. So what do we have? We have a 7 and then there's a 2 to the power 4. So I'm going to little bit expand this, which is not necessary for the answer, but to explain you, I'm going to expand this. Let's write this 2 to the power 4 as 2 into 2 into 2 into 2. This is your 2 to the power 4, and then you have a 5. Okay. See what I'm going to do. I already have 1 5 over here, and I'm going to multiply another 5, one more 5, and one more 5. Why did I multiply 3 5s? Because for this 5 and 2, I already have a pair. Now I made a pair for these two also, and I made a pair for these two, and am I making a pair for these two? So when you do this multiplication, if I multiply by 5 into 5 into 5 with the denominator, will it not be very easy to expand? Tell me, what is the denominator now, the new denominator?
2 power 4 into 5 power
2 to the power 4 into 5 to the power 4. Basically, we have, okay, but can we just go and multiply something in the denominator just like that? We can't do, no? If we multiply something in the denominator, we have to multiply by same thing in the numerator also. So don't forget to multiply that same thing in the numerator also. 5 into 5 into 5. So what is my numerator now? My numerator is 7 into 5 into 5 into 5. And my denominator, I'm going to write it as a pair. So this 2 and this whatever pairs I made, let me write 2 into 5, 2 into 5, 2 into 5, and 2 into 5. I'm getting 4 pairs like that, right? Now what is this? 10 into 10 into 10 into 10. I think you should be able to see the answer now, right? Just do the simple multiplication over here. What is that? Tell me what will be the numerator, guys. Someone do the calculation. All of you do the calculation. Tell me. What's the numerator?
775.
7, 7, 5.
Yes, sir.
Okay. And what's the denominator?
10 power
1000.
10,000. So what will it be? Tell me. 4 zeros are there in the denominator. So we'll go behind 4 places and put a decimal. So it'll be 0.0775. Okay, so since I have done all this, expanded everything, did all that calculation, that's why it may seem very lengthy. But let me quickly do it now. Same thing. Everybody understood what I did now? See, there was 1 5 was already there. If I could make 3 more pairs with 5 over here, then all these will be pair and they'll become 10, 10, 10, right? And when we have a number like 10 or 100 or 1000 in the denominator, the decimal conversion becomes very easy. That is why I brought that 5 extra 5s from somewhere else and made the denominator to be a multiple of 10 like this. Okay, so now let's do the proper way, shortcut way, how we will normally do it in your paper, in your exams. If you get this, you don't have to write all that steps. Okay, so let's say I tell you write the decimal expansion of 7 by 80. So what would you do? Very quickly go and do the prime factorization. So you will write it as 7 by 80 is equal to 7 by 2 to the power 4 into 5. And then in the next step, you just multiply this with, you know that one of the 5s is there. How many more 5s we need to make it equal to the power of 2? 3 more we need, right? So 3 plus 1 will become 4. So that if for each 2 we have 5. Everyone understands what I'm doing here?
Yes, sir.
Yes, sir.
Okay, got response from 3 people. Rest of the people, where are you?
Sir.
Okay. Anybody has a trouble with this?
Yes, sir.
All right. So numerator, there is no other way. You have to do the calculation. So 7 into 125, and then this will be 2 to the power 4 into 5 to the power 4. So what is that? 775 by, you know that 2 to the power 4 into 5 to the power 4 will become what? 2 into 5 to the power 4, which is 10 to the power 4 basically. And then since there are 4 zeros, you'll put the decimal before the 4 digits. So it will be 0.0775. Now, you may be asked to write the decimal expansion, or there may be another question from this same idea. Okay, let's see that also. We have exceeded the time, right? Okay.
Sir, 7 into 125 is 875, no, sir?
Is it? Okay, I didn't do the calculation. Is it 875?
Yes, sir, it is 875.
Okay, 875, whatever, okay. Fine, so you people understand, right? The logic behind it. If you have only 2 and 5s, so we will complete this thing formally. I will introduce you to the theorem and we will write that in the form of 2 to the power m and 5 to the power n. We will see what that means, okay, in the next class. So that's it for the maths class today, guys.